example, let's say that the question says it wants the area under the curve, and the curve is square root x, and they want it between, let's say, 1 and 5, and they said that they want it as an interval, 4 intervals, and they want to use the left Riemann sum. Okay, so first, you gotta show your work, right? So if you're gonna use your calculator, you gotta show enough work to say that, oh, I know how to do it, and I'm just gonna use the calculator to solve. But anyways, let's say you did. Next, you're going to use the calculator's program. To do that, you go to Program. You have 2 programs in there, Riemann. Okay, Riemann is the one you want. So click Enter. And then it's gonna say Program Riemann, and then press Enter again, and it enters into the program. The first thing is, okay, if you don't get it, please ask your partner. I'm just explaining to everybody. Somebody around you know how to do it. The first thing it says is settings f of x. So in f of x, you type in the equation. So square root x. Then press enter. Lower bound means the lower of the number, a, so 1. Upper bound is 5. Partitions is n. So how many you want? How many boxes? So it's going to graph square root x from 1 to 5. And then it says press enter. So you press enter. Next, you go to all the settings. First one, settings. Second one, left sum. 3, right sum. 4, midpoint. 5, trapezoid. 6, definite integral. And then 7 is quick. So you want the left Riemann sum. So you're going to go to 2. So you press 2, and then it shows you the box from the left-hand side. And then the sum is on the bottom, 6.14626. So that's the answer. Yes. Great. So if you want to quit this program, you press enter again. It goes back to the main menu, and you press 7, and it quits. Okay, so this is kind of useful for you to use for your homework and things like that. But remember, you can't rely on your calculator. You have to know how to do it by hand. Just know that sometimes if you want to check or you want to just get by really quickly, you can just do that. Okay? Yes? So we're going to do 4.3 for 2 days. We're going to do definite integral. Okay, so we had learned indefinite integral, and today we're learning definite integral. So so Riemann sum and definite integral is what we're learning for 2 days. Indefinite integral looks something like this: integral of 2x dx. Integral of 2x dx. What is the answer?
X squared plus x squared.
Good. X squared plus c. Don't forget the plus c. Definite integral is the same thing, except definite means that we have a lower bound and we have an upper bound. So it's going to have 2 numbers, from where to where. So the only difference is the definite integral has bounds, the indefinite integral does not. So the indefinite integral is going to have a plus c, and then the definite integral is not. So definite integral, you're going to have a x squared again, but you don't have a plus c because you're going to evaluate. And then when we evaluate, we write the line from 1 to 2. And then I'll show you how to find the number later. But that's what we're learning today, the definite integral. But the first thing is we need to remember Riemann sum from yesterday. Riemann sum, remember, is a sum of a lot of rectangles. Okay, so remember that it is a sum of the width, let's just say height times width. Height times width. Right, we're adding up a bunch of rectangles where the area is height times width. Recall that the width of the rectangle is just delta x, right? It's just how wide each rectangle is. Yes? And then the height is a function of where you are on the x. So it's the function of xi being where you are on the x-axis. And you're going to start with I equals 1, and then you end up at n. N is however many partitions or however many intervals you have. And when this gets really, really big, meaning when n is very big, you have tons of rectangles, then you get to the limit as n goes to infinity of the sum from I equals 1 to n of f of xi delta x. Right? Good. Now, this is kind of in general. Let's say that you want a definite integral. Definite integral means you have a starting point and an ending point, and you just want to find the definite area underneath that. You're not finding the everything area, just that part. So you have a starting point, you have an ending point. Because you have a starting point and the ending point, this integral is going to look, or this Riemann sum is going to look a little different. You still want to partition infinite amount, but the starting point is going to matter, right? Where you start and then you add on to the next one, right? Yes? So you're going to start at, let's say, theoretically, A, right? That's where you're going to start. You're going to end up at B. Yes? Okay, so then remember that delta x is the same as B minus A over n. That's how wide each one is. So you're going to start at A. Your next point where you're going to take the height is going to be delta x away. Yeah?
Yeah.
So then it's delta x away from it. Okay, and then we still have this part. So I'm going to rewrite this one last time. This is the same as limit as n goes to infinity of the summation notation of I equals 1 to n of f of a plus. So instead of delta xn, I'm going to say it's b minus a over n times I, because it's just how many i's over. Yes? I equals 1. No. I is 1 is the first x. The first one after the starting point.
The first one you plug in.
Right. Your first.
So I will always equal 1 at the bottom there.
Is I equal 0? Huh?
If it's 8,
Can I explain with the graph? Okay. So you have this graph, right? Let's say this is A, this is B. This delta is going to be how far you are. So then this first delta is going to be A plus delta x. The next one is going to be A plus 2 delta x. And so on. So I equals 1, 2, 3, 4, 5, and you keep adding.
but you only plus 1.
Yeah, what's I? You just made that up.
I is how many x's how many delta x you have.
So how many delta x's are away are you?
How many intervals away
Oh, wait.
from
That's
the
So I is interval.
Yeah, so I is interval.
I is interval? Yes.
Okay.
I guess in a way, yes.
So the b minus a over n, then there's an I next to it. If it
The I is
that times I.
Yeah, times I.
Okay.
But
I is the number of iteration.
Yeah.
But it's only once.
Iteration.
It's not once. It's 1 to n. N is infinity.
So
I-
Hold on. Raise your hand. Zach.
I thought we've been using n for number of intervals.
Yes, n is the total number of intervals, but I is the counting.
Oh.
Counts from 1 to n. Yes.
So to find the number of intervals, we do n minus I. According to that, right?
No, n is a definite amount, right? N is always just that number. But I is counting. 1, 2, 3, 4, 5. You count all the way up to n.
Sure.
Yes.
I get that.
N plus I.
But you did plus delta x I. Wouldn't we do plus delta x and then the next I? You know what I mean?
That little I is a counting It's a counter. It's like the first one, the second one. When you say the first one, you are not multiplying by 1. You're just saying this is the first one. This is the second
Then you
one.
keep adding, right? You add.
You add another delta x, yes. George.
N divided by I.
No, I is the count.
Number
You're the first one. Hold on. You're the first one, you're the second one, you're the third one. You're the counting.
Oh, so it starts with the first one. Right?
So
And you add.
delta xi means 1 means the first delta x. Delta x2. Oh my gosh, I think I have more hands down after I explain. Yes.
So is n the about numbers in the interval or the
Yes.
number you're going to?
It's the same. Those two things are the same. Yes.
Is this supposed to be really simple?
No, I get it.
The first time you see it, it's a little hard. Yes.
So to find the like actual number of intervals, do you do n divided by I? Because if like I was 4.
No, the actual number of interval is just n.
I just need
N
that.
tells you how
I
many.
always did like 1.
No, I is counting. 1, 2, 3, 4. It's a counter.
Like delta x.
Okay. All right.
Let's get rid of the I.
Let's go on.
There's no more I's.
Okay.
Just make it.
All right.
You work very
All right. So the whole idea is because I'm telling you that because we need to translate Riemann sum into indefinite integral by finding all those parts. So we need to translate that into integral notation. So that's a little bit tricky. So I'm going to help you to find it. All right. Remember that my summation notation is f of xi delta x. So I'm just trying to do a matching game. So delta x has to be this part. Okay? This is going to be my function. The question is what's going on inside, right? Well, I have this 1 plus blob. That blob looks just like delta x. So this blob whole thing is saying, I'm going to start at 1 and then I keep adding this delta x. I is how many delta x I add from the first number. Hold on. Hold on. Yes.
So it's 2a minus b.
Yes. Hold on. You're a little fast.
Yeah.
Yeah, it makes sense.
It makes sense.
Which part?
I was getting it and I didn't.
Okay. Huh? Okay, let me finish explaining and then I think this will make sense. Okay, so this is delta x. This is delta x. Remember delta x means b minus a over n. Okay? This is the natural log blob. That whole thing is my function. This tells me what number I'm starting. So this is a. This tells me how many delta x I'm trying to add to get to the next x value so I can evaluate. Okay, so 1 is going to be my starting point, plus delta x. Delta x is going to be my, I start at 1, add the delta x, add a delta x, add a delta x. So it tells me keep adding that I numbers away. So first one, second one, third one, so on. All right, so that's going to be my delta xn. So the whole thing is we are trying to find a, b, n. And, sorry, not n, we don't need n. F of x. Okay, a is going to be the first number, so 1. B is going to relate to this part.
3.
So b minus a is equal to 2, right? B minus a over n is 2 over n. Therefore, b minus a must equal 2.
Yeah.
Okay, a we know is 1.
So B is 3.
So b is 3. What? You guys have to raise your hand. There's just too many people talking. Let me finish. What do you think is f of x?
Natural log x.
Natural log x. Natural log x. Not 1 plus x. 1 is just my starting number. Natural log x. Okay, now rewrite this in integral notation. Integral from 1 to 3 natural log x dx. So this whole Riemann sum is just means this integral.
What?
That's not bad.
All right, let's try another one together. This one's just like the one we just did, but I'm just gonna help you. A, B, f of x. Let's do the easy one. What is A? 2. What do you think delta x is? 5 over n. Okay, so this is going to be b minus a over n. From here, you're going to figure out what b is. 7. What do you think f of x is? Natural log x. You have everything you need to write this indefinite integral. Okay, so integral from 2 to 7 of natural log x dx. All right, good. All right, yes.
So the lower number goes on the bottom?
Yeah, lower number always go on bottom.
Then higher number on top.
Yes, yes. Let's try this one on your own. All right, for this one, a is 0.
Yeah.
Okay, there's nothing, so 0. B is pi. F of x is cosine x. So from 0 to pi of cosine x dx. Okay, not too bad, right?
Yeah.
We're going to go backwards. So I give you a definite integral, you write the summation notation. Okay? To write the summation notation, you need a, b, delta x. Okay, what is a? 3. What is b? 8. Delta x is 5 over n. So b minus a over n. So 8 minus 3 over n, that's 5 over n. All right, summation notation is going to start with limit as n goes to infinity. The sum from I equals 1 to n of what? 3 plus
5i.
okay, 5i over n or 5 over n. Either way is fine. And then squared, not plus, times 5 over n. Yes. Okay, so you're plugging in a plus delta xi into the function being x squared.
Yeah, in for x.
Yeah, correct. All right, try another one. Whoa. Okay, just in case you didn't finish copying, I'm gonna leave it up there for 2 more seconds and then you're done? Okay. All right, try this one. Okay, so because of time constraint, we don't have a lot of time to practice. Limit as n goes to infinity of summation notation from I equals 1 to n of e to the 3 over n I times 3 over n. Nice. All right, now we're going to actually evaluate some of these integrals. So remember that integral is really just the area under the curve. So for example, this one, area under the curve between the curve and the x-axis. So when this area is above the x-axis, we're going to call that positive. If the area is below the x-axis, we call that negative. Okay, so very important. If it's below, it's negative. If it's above, it's positive. So let's go ahead and find some of these numbers. So number 1, the integral from 1 to 3 of 4 dx. All right, so the curve is what? 4. So it's just a flat line at 4. And this is evaluated from 1 to 3. So we're really looking for this area. 12, yes. So this is just 12. So a lot of these you can evaluate it logically without actually using calculus. It's just asking for the area under the curve.
8.
Huh? Is it 8?
I thought it was 8.
Okay. Sorry about that. 8. Thank you. I took the first answer I heard. Okay, this one. What is the curve? X plus 2. X plus 2 is just a diagonal line with an intercept of 2, right? From 0 to 3. So it's a trapezoid. So trapezoid area, B1 plus B2 times H over 2. So B1 is how long? Let's say the shorter one. 2. How long is the longer one? 5. So just plug in 3 into the function. So 5. How long is the height? 3. And then over 2. So that is 21 over 2. Okay, so area under the curve. Now I'm going to give you a more tricky one. This one. So this is the integral from -1 to 4 of this graph. -1 to 4. That is this area plus this area. Notice the negative area. Negative area is going to subtract out. Okay, so the question is, what is the total area under this curve?
So find the trapezoid and then find the trapezoid and then subtract.
Right.
Or mentally just kind of start adding and subtracting areas.
So you got 2. Oh wait, that's half.
This is positive, this is negative. Answer? 2.5. All right, so the important thing is just adding and subtracting. This one, they have this function. This function is such like this. The question is, first one, g of 0. When they're asking g of 0, they're saying plug in 0 for x. Okay, plug in 0 for x. So we want the area under the curve from -3 to 0. So trapezoid.
2, 1, 3.
Yeah.
9 over 2. I did not get 9 over 2.
2 plus 1, 3.
Yes, I think it's not over 2.
Over 2. Over 2.
I think I got 6.
What?
9 over 2? Oh, I'm sorry.
I keep getting
Okay. What about this one? G of 2. G of 2. G of 2 means from -3 to 2. All right. Next week.